So in this video, we're going to find the radius of convergence of this power series. So we've got x to the power of 2n divided by minus 8 in brackets to the power of n. So this is going to be some sort of alternating series. Okay, well, first of all, we see here our x is on its own. Normally in some of these questions, we see x minus a to the power of some n. So in this case, a equals 0. So with that in mind, we're still okay to continue from where we are. So a equals 0 is not a problem. Okay, so how are we going to find the rate of convergence for this? Well, first of all, we need to use something to try and help us with this 2n in our numerator term. So what I'm going to use here for this power series, I'm going to use the root test. So in the root test, what we do is we take this term in the power series, and what we do is we raise it to the power of 1 to the n. And then we find the limit as n approaches infinity. So let's go straight for that. So as limit as n approaches infinity of this term here, so absolute value x to the 2n divided by minus 8 to the n. Okay, and then what we do is we raise this to the 1 over n. So that's what's called our root test. So that's how we would go about that. Okay, so now what we need to do now is try and do the algebra on this. So now we've got the limit as n approaches infinity of absolute value x to the 2n. Now if we raise this to the power of 1 over n, and then we've got minus 8 to the n, all raised to the power of 1 over n. So that's how we take care of that first. Okay, so x to the 2n raised to the 1 over n, that now will just become x squared. So limit as n approaches infinity, absolute value, this will be x squared. And then minus 8 in brackets, n to the 1 over n, these will cancel each other out, and then we're just going to be left with minus 8. Okay, now as we've got absolute values, what we can do is now we can take away this minus 8 sign, and now we're just left with the limit as n approaches infinity is of x squared over 8. Okay, so now the limit as n approaches infinity for this term, there's no n involved in here, so this just equals x squared over 8. Okay, now we're interested in a radius of convergence. Now for any power series to converge, what we need is our limit to be a value less than 1. So what we do now, we set our x squared over 8 to be less than 1. That way then, for all the values for x squared over 8 which are less than 1, this series will converge. So let's do the workings on this one. So now if we multiply both sides by 8, we've got x squared is less than 8. And now square root both sides. So if we take square root of that, square root of that, we've then got x is less than plus or minus square root of 8. So then that leaves our interval here that we're interested in is minus square root of 8, x, which is going to be larger than minus square root of 8, but smaller than square root of 8. So that's our interval of convergence that we're interested in. But what we need to do now is just check our endpoints. So what I'm going to do is I'm going to take this off the board, and then we're going to look at our endpoints on our interval of convergence. Okay, so now let's look at our endpoints. Let's look at square root of 8. So now what we do is now where we see an x, we plug in square root of 8 for our power series. Okay, so now we've got n equals 1 to infinity of square root of 8 to the power of 2n divided by minus 8 to the n. Okay, now this one here, we want to break that down to minus 1 to the n and multiply it by 8. So we get minus 1 to the n. So that's a series that we know in power series. Now this one here, square root of 8, if we bring this 2 inside there, then we can square that and get rid of this square root sign. So let's do that. So n equals 1 to infinity. So bringing this one up first, square root of 8, and that will be squared. So that takes care of that. So put that in brackets and then raise that to the n. And then what we do is now we'll break this one apart and have minus 1 to the n and multiply that by 8 to the n. So that way then we've got the same terms here. That is just the same as that. Okay, so now we can simplify this. Square root of 8 squared is just 8. So let's do that. So now as n equals 1 to infinity, we've now got 8 to the n over minus 1 to the n times 8 to the n. Okay, well we can see straight away that these will cancel out. So now we've got power series n equals 1 to infinity of 1 over minus 1 to the n. Okay, well this will just simplify off now. So that will just become n equals 1 to infinity of minus 1 to the n. Now we know that this series here diverges. So this series, just right here, diverges. That's a well-known alternating series. So as these points here, this one here, in particular square root of 8, we know that that point is divergent. So therefore, we need to be inside square root of 8. We don't need to include it. Now minus square root of 8, if we plug that into here, as we're squaring it, we'll still get the same answer as we did for the right hand side of this inequality. So therefore our interval of convergence is, as we said here, having checked the endpoints, we know they're not included. So x is in between square root of 8 and minus square root of 8. Now we could simplify that off to minus 2 root 2 is less than x, which is less than 2 root 2. So we could also simplify it off to that. So that is our interval of convergence. Okay.